Welcome back to lesson 3, Monday the 11th of May. We're going to do mathematicals and then we're going to talk about angles. Okay, so if you've got this sheet, obviously just put your name at the top so you can send it to me. If you haven't got it, please head up your book, week 4, Monday the 11th of May 2020. Okay, so the time, so if you just have a look at the time, hopefully there's a clock nearby, and write in digital time, AM or PM. The shorthand's your hour hand, so that's the first time you put in for digital time, and then count round your minutes. Okay, we're simplifying 20 over 25 or 20 25ths. So what number goes into both of those? The answer is 5. So how many times does 5 go into 20, which is 4, and how many times does 5 go into 25? 5, so the answer is 4/5. Change the pentamino to another. Okay, so a pentamino is, I will read you the actual definition of a pentamino. A pentamino is a polymino of order 5. That is a polygon, and we know that a polygon has equal sides more than 3, in the plane made up of 5 equal sized squares connected edge to edge. So what it is 5 equal squares connected edge to edge to make a pattern. So all you need to do is take this shape, which has 5 equal squares attached edge to edge, and you make a different shape out of it. That's all they want you to do. Question 4, 600 plus 900. So you add your 9 and your 6, and that gives you 15, and then you add your 2 zeros on. Add brackets to this number sentence. So the BODMAS rule is brackets, order meaning that we're doing numbers that are the power to or exponents first and square roots. Then we're doing division, multiplication, addition and subtraction. So your first bracket would go around 3 divided by 3. Your second bracket would go around 6 multiplied by 4. 3 divided by 3, remember very neatly writing your number above the brackets is 1. 6 times 4 is 24, so 24 plus 1 equals 25. 29.3 divided by 10, remember when you're dividing the number gets smaller. We have 1 0, so we are going to jump this decimal point 1 point to the left because there's only 1 0 and we're making the number smaller. So 29.3 divided by 10 has 2 tens, 0.93. 10 take away 0.2, we make that 10.0. As soon as we take 0.2 away from a whole number, it becomes one whole number less. So that's 9. So then we're taking 2 away from the whole after the decimal. So 9 point, what's that going to be? If we have tenths and we take 2 away. 8. So it's 9.8. How many diagonals? I'll let you figure that one out. Adding these 3 numbers, a small truck has a tear of 4,500 kilograms and an aggregate of 8,000. How many kilograms can it carry? So we're taking this one away from that. We're rounding 7.89 to the nearest tenth. So we've gone over 0.5 here, so we round this up to 8. Draw an arrow to show the concave face. So what does concave mean? I'll just pause this and pull up an image for you. Okay, so a concave, just wanted to show you, is this part of arc. Okay, it's the bit arcing out. So what the question is asking you to do is draw an arrow to the concave part. So that would be the top part of the concave. 100 divided by 10, we should know how many tens are in 100. And when we're dividing by 10, a really easy way, there's 1 0 there, so we take 1 0 off. Is 153 divisible by 9? Yes or no? So that means does it go into it? And if we even just look at that now, we can see that 9 can easily fit a number of times into 153. But if we actually wanted to work it out as a division, which I think is a good idea, so 153 divided by 9, 9 goes into 1, nope, doesn't fit. 9 goes into 15, once, and how many over? 6, and 9 goes into 63. Have a look at your little multiplication chart. I'm not going to do it all, and it actually goes in evenly. Okay, so yes, it does, and you can write that last number up after you check it. That's me trying to get you to have a look at your multiplication chart. Okay, 1.2, then there's a space, 0.8 and 0.6. So what are these numbers going down by? We can't compare anything here because we don't have it. 0.8 and 0.6, they're going down, and how much are they going down by? 0.2. So if we take a 0.2 away from this, what are we left with? 1.0. We're left with a whole number. So write that one in. The Roman numeral M and X, if we have a look at Roman numerals, M and X. So this time M is 1,000 and the X is after that, so would it be 1,010? So 1010, 1010. Okay. How many B boxes fit evenly into an A box? So if we have a look at this, we've got 3 centimeters going this side and 2 centimeters going this side, and this box is 1 centimeter cubed, 1 centimeter long by 1 centimeter wide by 1 centimeter tall. So it's 2 here, so we can fit 2 in the front, and including this one we can put 3 behind. So basically 2 times 3. 1 hectare is equivalent to how many meters squared, and that's something you just kind of have to know. So that's 10,000 meters squared. We're adding these two numbers, which I'll let you do, and 10 to the power of 4. Now this is what I was talking about with your BODMAS. It's called an exponent, and it's when you have a whole number and you put it to the power of, and this one's to the power of 4, and this bit here, that is your exponent. Okay, so it's not 4 times 10, it is 10 by 10 by 10 by 10, and you can use a calculator to work it out. So you're saying 10 times 10, which is 100, 100 times 10, which is 1,000, and then 1,000 times 10, which is 10,000. So think of it as this number is building this number, then this number together is timesing this number, then this number, that number, and this number go together to times that number. Okay, it's a growing pattern. It's not one, then the other, then the other. So when you see those in brackets, those exponents, that's the order, and you do those inside brackets first, then you work out what the whole bracket is. Okay. Let's close those up and go back to Edge Studio and have a look at what you need to do. Now, there is a angles test on here, which we'll go through and work together. Now, I don't give answers out for tests, but what will happen is we're going to go through it and you can send it to me, and I'll definitely put it in the student folder. But when we go back to school, and the chances are we will be back in week 6 all going well, I'm going to give the students these tests again. The tests for this term are BODMAS and angles. So there's some students that aren't returning those, so to make it fair to everyone, and if you've done it at home and you're feeling good about it and you come in, that means you can do it easily at school. But there's some students that haven't looked at it or done it at all, and they will have to go over the material and do it when we get back. So we'll do this one tomorrow, don't worry about that. So let's have a look at the PowerPoint and we'll go through that. And so what they're saying is this is what we're learning about, and we're going to complete an activity and then you do your test within an hour, whatever. Okay, so let's have a look at this one and use that as a bit of a learning activity to do with angles. It looks complicated, but it's not. It's easy. Okay, so we know that a straight line's 180 degrees. A full circle is 360 degrees, which is 2 halves, 180 plus 180. So when we want to work out what B is, and you can use a calculator for these, and I will be using a calculator in class, is you add these two, 60 and 40 is 100, and then you take 100 away from 180, and we can do that now. That's 80 degrees, so B is 80 degrees. So we're just working purely on the idea that we know what a straight line is, which is 180, and we're taking away what angles are there to find the letter. Okay, so 40 and 10 are 50, 180 take away 50 is 130, so this angle here is 130, and we can see that's correct because it's more than a 90-degree angle, so we write 130. So as well as just quickly going through and writing the answer, have a look at it and familiarize yourself with that angle. So for this one straight up, you could see that that is a right angle and that's 90 degrees. Okay, 50 and 75 taken away 180, there's your angle there. It's the same all the way through. Okay, with this one you're taking these two away. Are these two similar? Yes, they are, and there's your 98 there. So you add that, and then you take it away from 180. They look very similar, those angles though. And it's just good to have a look and see, oh yeah, those angles are similar there. This one's bigger than 90, this one's under 90, okay, and you just go through and work them out. They're the same thing over and over again, okay? And don't have a look at the answers at the back. So that's all I want you to do today, and be really comfortable with doing that and understand it. Just have a little think about it. What your acute angle is less than 90, your obtuse is greater, a straight line is 180, you've got your right angle which is 90 degrees, which can go any way. These are called rays. Your corner bit's called a vector. Yeah, just be really familiar with all that. And then tomorrow what we'll do, and you can open it up today and have a look at it if you want, we'll go through this test the same way we did it last time, but of course I'll be printing those out and giving them to you when you come back to school, and we'll go through them together as well, just to make sure everyone's doing it under the same testing condition. But it's good for you to do it now to familiarise yourself. And that's it for angles. There's a couple of activities down here where they just talk about what we talked about here with the straight line and finding it, and how opposite angles are the same. That's 50, that's 50, that's 123, that's 123, and they just give you a little bit of an explanation on how to find the missing angles. Okay, so that's it for today for maths. Have a great day, and I'll see you tomorrow.